Greetings, ladies and gentlemen. I do welcome you all to TV Math Hub. I welcome you all in our today's lecture. Today we shall be talking about differentiation of trigonometric functions. We have so far looked at the differentiation of trig functions that have got a single angle, and today we shall be focusing at differentiation of trig functions that have got multiple angles. We shall begin with differentiation of cos 2x. So, to differentiate cos 2x from first principles, we shall first of all let y to be equal to cos of 2x. Then an increment in x will bring about an increment in y, and for that case, we shall be able to have y plus delta y is equal to cos of 2 into x plus delta x. So, we shall be able to make delta y the subject. So making delta y the subject, bring this y the other side, and it becomes minus. So it becomes minus y, but y is cos 2x. So for that case, we shall have delta y, which is equal to cos of 2 into x plus delta x minus cos of 2x. If you recall very well, from there we shall be able to apply what we call the factor formula. And to recall, we said the factor formula, if you are dealing with cos of A minus cos of B, it will be same as minus 2 sine of A plus B divided by 2, then sine of A minus B divided by 2. So for our case, this will be like our A, and 2x will be like our B. So that's why we have delta y, which is equal to minus 2 sine of 2x plus 2 delta x plus 2x divided by 2, then sine of 2x plus 2 delta x minus 2x divided by 2. So that is what we shall have. And from there, we shall be able to simplify this. On simplification, we shall be able to remain with delta y, which is equal to minus 2 sine of 2x plus delta x, then sine of delta x. 2x and minus 2x will give us 0. 2 delta x divided by 2, we shall remain with delta x. Then 2x plus 2x is 4x divided by 2, we shall remain with 2x. Then 2 delta x divided by 2, we shall remain with that. So on simplifying, we shall be able to get delta y, which is equal to that. So from here, we shall now divide through by delta x. So dividing through by delta x on both sides, we shall be able to remain with delta y upon delta x, which is same as this same expression divided by delta x. So from there, we shall introduce in what we call the limit. So taking limit on both sides, when we take limit on both sides, we shall be able to have this given expression, that is taking the limit as delta x is tending to 0. Of course, in this one, we shall be able to get this expression here. So from there, we shall make our assumption that as delta x is becoming smaller, then delta y, delta x will be approximately equal to dy dx, then sine of delta x will be tending to delta x. So let us substitute for that. As delta x is tending to 0, this one will become dy dx, then sine of delta x will remain delta x. So for that case, we shall be able to have dy dx, which is equal to the limit delta x tending to 0 of minus 2 sine of 2x plus delta x, then sine of delta x is becoming delta x, then we are dividing the whole of this by delta x. So clearly we can see that delta x will cancel out, and we shall be able to remain with dy dx, which is equal to the limit delta x tending to 0 of minus 2 sine 2x plus delta x. Delta x and this one has gone, because this divided by that will give us 1. So we shall be able to remain with this expression. So since delta x is becoming smaller, So in this expression here, where there is delta x, we shall simply substitute delta x with 0, and we shall be able to remain with minus 2 sine of 2x. So for that case, we shall get dy dx as minus 2 sine 2x. So this implies that when you differentiate cos 2x with respect to x, you will get minus 2 sine of 2x. We need to come to the differentiation sine 2x. So I encourage all of us to kindly subscribe to this channel to make sure that you keep updated of whatever the videos that we upload. So we want to look at the differentiation of sine 2x. So using similar procedures as we did in our previous case, we shall first of all let y to be sine 2x, then an increment in x will bring about an increment in y. So for that case, we shall make delta y the subject, and making it the subject means we are taking this y at the other side, but y is sine 2x, so delta y becomes that. So from there, we shall be able to use factor formula, because this is sine followed by sine. So we shall use factor formula, and by factor formula, we shall be saying that if you have sine of A minus sine of B, it is same as 2 cos of A plus B divided by 2, then sine of A minus B divided by 2. So for our case, this will act as our A, and this will act as our B. And using the similar expression, we shall be able to have delta y as this. So we shall have our next expression as delta y, which is equal to 2 cos of 2x plus delta x sine of delta x. That is after simplifying. So on simplifying, this is 2x plus 2x, 4x divided by 2 shall give us 2x. Then 2 delta x divided by 2 shall give us delta x. 2x will cancel, we shall remain with 2 delta x divided by 2, which is delta x. So on simplification, we shall have that as delta y. So next we shall have to divide through by delta x, and on dividing through by delta x, we shall now have delta y over delta x, which is equal to this same expression here, 2 cos of 2x plus delta x sine of delta x. We are dividing through by delta x. So that is what we have for delta y divided by delta x. So that will be able to give us delta y upon delta x, which is 2 cos of 2x plus delta x divided by delta x. That is the same expression we have seen. Then the next procedure is to divide through, or to introduce what we call the limit. So we shall introduce the limit as delta x is tending to 0 on both sides of this equation here, and we shall be able to remain with this expression. And from there, we shall take our assumption that if delta x is becoming smaller, delta y delta x tends to dy dx, and sine of a small angle remains that angle. So that will bring us to dy dx, which is equal to the limit of delta x tending to 0 of sine, where there is sine of delta x, we are putting delta x, so we shall have delta x divided by delta x, and in our next procedure, delta x and this one will divide, and we shall get 1. So we shall be able to have dy dx, which is the limit, delta x tending to 0, delta x with delta x gives us 1, so we remain with this expression here. So from there, we shall have dy dx, which is equal to 2 cos 2x, because delta x is becoming smaller, and as delta x is tending to 0, it means where there is delta x, we shall put a 0, and that will be our expression for the y dx, meaning that the y dx is equal to 2 cos 2x. In other words, this implies that when you differentiate sine 2x, you get 2 cos of 2x. So that is the expression, or that is what we get when we differentiate sine of 2x. So clearly, differentiating sine 2x, you get 2 cos of 2x. We shall now come to the differentiation of cos a half of x. So looking at the differentiation of cos a half of x, we shall follow the same procedures as we have done for sine 2x, cos 2x. We shall first of all let y to be cos a half of x. An increment in x brings about an increment in y. And for that case, we shall make delta y the subject by bringing y the other side. But remember, y is cos a half of x. Why is this? So it means we shall be having delta y equaling to cos, simply multiply this a half inside. You will have a half of x plus a half delta x, then minus cos a half of x. You need to recall that this is now an expression that will bring us to what we call the factor formula. So we shall now apply the factor formula, and when we apply the factor formula, you recall very well, if you have cos of A minus cos of B, we said this is negative 2 sine of A plus B divided by 2 sine of A minus B divided by 2. So for our case, this acts as our A and this acts as our B. So using this expression here, we shall be able to remain with delta y, which is equal to minus 2 sine of A plus B, a half of x, a half delta x plus a half of x, everything divided by 2. Likewise, A minus B, which is a half of x plus a half delta x minus B, which is a half of x, divided by 2. So on simplification, this is a half of x plus a half of x. That is actual x, but we are dividing it by 2. So we shall have this one here giving us x divided by 2, then plus 1 over, this is 1 over 2 delta x divided by 2. So this becomes a quarter delta x. Likewise, this and this will move away. We shall remain with a half of delta x divided by 2, which will give us a quarter of delta x. So when we try to simplify that, we shall be able to obtain delta y, which is equal to minus 2 sine a half of x plus a quarter delta x sine a quarter of delta x. So from there, we shall have to divide through by delta x on both sides, and this will be able to give us delta y upon delta x, which is this same expression here divided by delta x. So that is basically what we shall have. So next we shall be in position to bring in our limit. So when you take limit on both sides, so you are taking limit of this one and on both sides, both on the right and the left hand sides. So we are taking the limit as delta x is tending to 0, and of course from there we shall make our assumption that when delta x is becoming smaller, delta y delta x will tend to the y dx, and likewise sine a quarter of delta x will of course be tending to a quarter of delta x. So from there, it means where there is sine a quarter of delta x, we shall have a quarter delta x, but we are dividing it by delta x, meaning that delta x will cancel out in our next procedure, and we shall basically remain with a quarter times -2, which will give us -1/2. So it means dy dx is equal to the limit delta x tending to 0 of -1/2. A half is coming from -2 divided by -2 divided by 4. So it will give us -1/2 then of this one here. So that is the expression we are remaining with. So from there we shall be able to say that dy dx is same as -1/2 sine 1/2 of x. That is when delta x tends to 0. It means this delta x will be substituted with 0, and we shall only remain with -1/2 sine 1/2 of x. So that implies that when you differentiate cos 1/2 of x, you get what we call -1/2 sine 1/2 of x. We shall put this note that when you are looking at multiple angles, you differentiate the angle and multiply with the derivative of the trigonometric function. So when you differentiate the angle, for example, for this case, when you differentiate the angle is 1/2 of x. When you differentiate it, it becomes 1/2. So then you will multiply it by the derivative of the trig function. The trig function we are having is cos. So when you differentiate cos, as we saw in our previous lecture, you get negative sign. So it means you will get what you obtain after differentiating the angle, which is 1/2 of x. When you differentiate this, you get 1/2. So you get 1/2 multiplied by the derivative of cos, which is negative sign, then return at the same angle. So you can use that to differentiate all other expressions for trig, especially those that have multiple angles. So we shall look at our next differentiation, which will be basically talking about differentiation of the tan. So how do we differentiate tan 2x? So to differentiate tan 2x, we shall be following similar procedures. So we shall let y to be tan of 2x, then it means if y is equal to tan 2x, an increment in x will bring about an increment in y. So that implies y plus delta y will give us tan of 2 of x plus delta x. So from there, we shall make delta y the subject by bringing y on the right hand side, and we shall be able to remain with delta y, which is equal to tan of 2x plus 2 delta x minus tan 2x. For that case, we don't have the factor formula that relates tan, so we must express tan in terms of sign. So we shall have tan in terms of sign. It will be sine of 2x plus 2 delta x divided by cos of 2x plus 2 delta x minus tan 2x is same as sine 2x divided by cos of 2x. So from there we shall actually get the LCM. So the LCM of this expression here, of this one and this, these two fractions will be cos of 2x plus 2 delta x, then times cos 2x. So on computing, we shall be able to remain with this expression, that is delta y equaling to this, meaning that you are getting this LCM divided by this, you get cos 2x multiplied here. So that is what we have. Get this same expression, divide it by this, you will get this expression multiplied here, and that is exactly what we have here. So from here we can easily see that if this is, for example, A, this is, for example, B, this is B, and this is A. If you recall from compound angles, if you have sine of A minus B, it is same as sine of A cos of B minus cos of A, then sine of B. That is what we get. And clearly, you can easily see that this is sine A, this is cos B, this is sine B, this is cos A. So looking at this and this one, they are actually the same, meaning that this expression here that we have in the numerator is actually an expression of sine of A minus B. In other words, it is sine of A, which is 2x plus 2 delta x, then subtracting B, which is 2x. So that is what we shall have when we try to simplify that. So we shall have our delta y as sine of 2x plus 2 delta x minus 2x, then the denominator remains the same. So on simplifying that further, we shall be able to have 2x minus 2x giving us 0, so we remain with sine of 2 delta x. So this is the expression we shall get on simplification. So from there, we shall divide both sides by delta x. So divide the right hand side and the left hand side by delta x. So we shall have delta y divided by delta x, which is equal to this expression here on dividing by delta x. So from there, we shall take our limit. So let us take the limit as delta x is tending to 0 on both sides. So this is what we obtain. So from there, we shall make our assumption that when delta x is becoming smaller, delta y delta x tends to dy dx, and sine of 2 delta x, if delta x is becoming smaller, then it is equivalent to 2 delta x. So from there, we shall therefore have a limit of delta x tending to 0 of delta y delta x, which is equal to that, where we had sine 2 delta x, it is 2 delta x. So as we said, limit of this is dy dx, so we shall have dy dx, which is equal to delta x will cancel out, this and this will give us a 1, so we shall remain with this same expression. So we shall be saying that since delta x is becoming smaller, it means 2 delta x will go to 0, and we shall remain with cos 2x times cos of 2x. So that gives us dy dx equaling to 2 divided by, this is cos 2x times cos 2x, which will give us cos squared of 2x. But what is 1 divided by cos squared is same as sec squared. Then the angle is 2x, and here we have 2. So 2 divided by cos squared of 2x is same as 2 sec squared of 2x. In other words, it implies that when you differentiate tan of 2x, you get 2 sec squared of 2x. Likewise, as we said, when you are differentiating multiple angles, when you differentiate the angle, which is 2x, you will get 2. Then when you differentiate tan, you get sec squared. So you get the what you obtain, the derivative of the angle, which is 2, multiplied by the derivative of tan, which is sec squared, then simply put back your angle, which is 2 of x. So dear ladies and gentlemen, this is where we shall stop for today, and kindly please subscribe, like and comment to our videos. Thank you so much and have a blessed time.